Well, today's sticker comes all the way from Quincy in California, and the gentleman that sent me this is named Joe Way, and he runs a channel called Sierra Specialty Auto. Now, he does a lot of the same sort of stuff that I do, but he's also into vehicle maintenance and vehicle restoration, so if you like that sort of thing, you can check him out. But the best thing is that this came postmarked all the way from Sacramento in California. And Quincy is not in Sacramento, it's sort of northeast, I think, just looking at the map. But Sacramento is also the sort of the gateway for Yosemite National Park. And a couple of years ago, my wife and I were in California, we're in San Francisco actually. We desperately wanted to go to Yosemite, and we booked a tour, and it almost worked out, but the timing was all wrong. And we thought, you know, we're going to go back and we're going to see that. And then, well, COVID, so it didn't happen. But still on the agenda, still hoping to get there. And California is just one of those amazing places. But I just noticed on the map this morning, they've got another wildfire. So I hope you're okay, Joe. But there you go. Check out Joe's channel. But for now, let's go and see what's on the bench. So this video is going to be part show and tell, part build video, and the reason for that is I've already done part of the project. So this is my welding bench. Now it's 4 foot square and it's 8 millimeters thick. Now it's not heavy as welding benches go, but it's adequate for what I do because I'm not a welder. And what I want to be able to do is to mount a vise on the edge of the bench here, but I don't want the mounting for the vise to protrude above the surface of the bench itself. So in other words, I want to be able to make the top of this bench clear as much as possible. Now if I was to mount the vise there permanently, this is where it's going to go, but if it was there permanently, it'd just get in the way. And I don't need it every day, so I want to be able to just mount the vise, take it off again when I don't need it. So this is what I'm proposing. Now I've made up this fabricated socket, and it's got a piece of heavy hot rolled steel stock with a couple of M12 holes in it, and a collar. Now the collar was made from this material here. Now it's a heavy wall steel tube. This is actually used to make hydraulic cylinders. And as it turns out, I had a piece of this hard chrome steel bar stock, and it's an accurate fit inside that tubing. So that's what I began with. So I've cut a piece of this stock, the steel bar, piece of the tube, and I've fabricated up this socket here. Now it's got a pinch bolt on the side with 2 welded on lugs, and I slit through this piece of steel tubing with a 3/32 slitting saw. Now these little lugs, they were machined up on my little CNC milling machine. You can see it here beavering away and chopping the ends off that and making it truly semicircular on those lugs. I also mounted the same lugs as a pair in the vise on the Bridgeport, and I used my boring head to actually bore out a radius that matches with the circumference of this steel tubing. And then after that I was able to clamp everything in place and just do a rough and ready sort of weld around those lugs. Now, I put a pair of washers in between when it was all lined up, so that when it was fastened in place and the M8 pinch screw goes through there, I had the accurate gap already between those lugs. Now I did the same thing on the CNC milling machine. I machined out this radius to match the outside diameter of that tubing, and that's been welded in place as well. So in practice, how does this work? Okay, let's have a look. So what will happen is our socket will go underneath, and our pair of M12 countersunk head screws will go through from the top, and these are just slightly subsurface, so there's nothing to catch if you slide a heavy job across the top of the welding bench. And this can be tightened down. Alright, so as you can see, that's clear on top there now. There's nothing going to catch with those screws. And then our socket can adapt to a number of different accessories that goes into this hole here. I can fit whatever I want into this socket here, but first and foremost we're going to fit the vise. So this is a plate that I've fabricated up for the vise. It's got a piece of that same hard chrome steel bar stock welded to the bottom of this 6mm thick steel plate, and there are 3 studs welded into the top. And that will fit into the socket, and now we can rotate that wherever we want that to go. Now this is the vise that I'll be using. It's an old Dawn vise, cast iron. It's the first engineering vise that I had at home here. It was a bit of a Frankenstein that came out of a scrap box at work, and had a broken nut in the back of the vise. So I've machined a new nut for the vise, and that could mount on those 3 10mm studs like that. And now we can rotate the vise wherever we want that to go and lock it off with the socket head screw underneath there. But we can also fit other accessories into this socket. So I want to be able to fit my small anvil on the bench here, and also a number of what I call stakes, or that's what we call them here in Australia. And they've got a square socket fitting. And I'm going to make that now, and we'll get that ready to go in. And then we'll look at the vise when it's finished. And yeah, it's all coming together. So let's have a look at how this socket's going to work for the stakes. These are just 2 of the stakes that I've got, and I think I've got 5 of these all together, and they come in all different shapes and sizes. These are mostly for sheet metal work, and you can form up curved work and flat work over these different stakes here. This one's just called a dome stake. This is a half moon stake, and they all have in common this tapered end on them. And these are designed to go into a bench with a tapered socket, or at least a square socket, which accepts this tapered section here. Now what I want to do is to fit it into my little adapter that I've already got on the bench here. So let's have a look at how that might work. So as you can see, that tapered end on the stake will fit into that socket there, but it's really not going to locate that accurately or positively. So what I want to have is some sort of a cylindrical sleeve that goes in this adapter here. It'll have the correct taper and the correct square shape to match that socket, and then I can clamp that up fairly tight, and it's not going to wobble around too much. However, part of the problem is that these square shanks here are all different. I'm guessing that these things were forged and they didn't take a lot of care to make sure they were uniform, and you see that they're different lengths, they're slightly different sections, and the benches that we had for accepting these stakes here just had a square steel plate on top and a bit of a square hole through a wooden beam underneath. And over time they just sort of wore and sort of matched the shape of these square shanks here. But in my case I want to make the fitting out of steel, so it's going to have to fit this fairly accurately. So if you had a wire EDM machine, no problemo, but I don't have one, so we're going to have to make something the hard way. So let's have a look at that. Okay, so what I've done is I've cut 4 pieces of 10mm thick hot rolled steel plate, and these have been tapered and sized so they more or less match that tapered shank there. Now remember, they're all different, so I just picked one at random and I tried to make these fit that particular one. Now in practice they're going to wobble a bit, but I reckon we can get a more solid mounting than just putting it straight into that circular socket. So the plan is to first of all tack these together as a pair, and it's going to be done roughly like that. And then once we've got tacks on the 2 corners, I'll tack up the other pair. Then we'll make a full weldment out of the whole thing, and then we're going to weld up all of that square shoulder there. And when we've got that done, I'll machine this to a circular shape to fit our socket. So I've just got a bit of square tubing clamped to the bench and our 2 pieces clamped to that. These parts were just sawn on my little metal cutting bandsaw. It was a bit slow, but I got it done. And then they went into the milling machine, and I just milled them so the edges were reasonably flat. Now this first one here I just did with an angle grinder. It didn't come out that good. But given that it's all going to be covered in weld, I don't really think it matters. Well, I'm not sure if you can see that, but these ends aren't even square and they're all different. So I've just taped this one together around this particular shank, and we'll get it tacked, but almost certainly they're all going to fit differently. But at the end of the day, it'll seat home. Because it's tape, it'll seat down into the socket and more or less stay there. So we'll go ahead and get this one tacked, and then I'll do all the welding, but I'm going to do that pretty much off camera because I'm a shocking welder and I don't want to be judged. Okay, well, I'll get the corners filled in now, and then the fun and games begin on the lathe. Okay, well, I'll do the rest off camera because you're not likely to see anything anyway. Plus, I don't want to be embarrassed. Well, there you go, it's not pretty, but it'll do. And nearly all of this weld is going to disappear except for what is right in the corner of that root between the two plates here. So, of course, the question is, does it fit? Well, yes, it does. But if you look down in here, you'll see there is a gap. But if I tried another one of these stakes, the gap will be somewhere else, or it'll be a different size. But at the end of the day, that's quite solid, and it can actually be a nuisance sometimes if these fit too tightly. It's hard to get them out, and the idea is that in practice you can take them out and rotate them 90 degrees. Now, in my situation here, I can rotate them anywhere I want by loosening off the socket on the end of the bench. But I do want it to fit without rattling around too much. Okay, now the next step is to get this in the lathe somehow and machine this to be circular and to fit the socket. Now there's two ways to go about it. There's the correct way, which is to mount this on a mandrel, and that would mean machining something which is going to fit and touch tangent to all four corners there, and then probably tack that on. And then there's the really sketchy way, which is holding it in a 4-jaw chuck and trying to get it lined up and then machining this end first. So I'm going to try the sketchy way first, and if that's no good, then we'll mount it on a mandrel.
Time to do some sketchy shit. Doo-dah, doo-dah, hope I get away with it. Oh, doo-dah day.
Well, here's a setup that the Dodgy brothers would be very proud of, and all I've done here is I've mounted the fabrication in a 4-jaw self-centering chuck. Now the problem with that is that if your material is not perfectly square, it's really only gripping on 2 jaws, and the other 2 are sort of taking a free ride really. And to save you the anxiety of watching me do this, I faced that off camera, and I took it very slow with a light cut until I cleaned up all of that surface. And the other thing I've done here is I've bored this out just very, very slightly to take this plug. And with that inside there, I can grip the end with the tailstock center, and that gives me some lateral support at this end. I can machine off this outer surface here until it gets down to the diameter of the inside of the socket. At that point we can flip it, do the other end. Alrighty, that's looking pretty gnarly. I'll get a dimension across this diameter here and we'll bring it down to the size of the socket. Alright, we're very close, about 1/2 millimeter off the size that I need, and you can see the difference between the hot rolled steel and the weld metal. The weld obviously is harder than this stock here, and that's why we're getting the dissimilar finishes. And this carbide insert's really not suitable for this softer steel, so I'm going to change over to high-speed steel, finish that off, and then I'll chamfer this and we can flip it around. It didn't quite clean up. So a few little flats there. I'm not too bothered about that. Alrighty, do the other end. That's a shame. If I go much smaller, we're going to weaken this corner, and we're not quite cleaning up the flats here. But I think what I'll do is I'll back taper this back down to this shoulder here, and that'll get rid of most of the flat. We might have to live with these. Well, unfortunately we didn't quite clean up the flats, and they're all different, which is a bit annoying. Well, I'll flip it around now, I'll get this back edge cleaned up, and then I'll make a decision about what I do with that. I may just, what can I do? I could actually mill those flats and make them more uniform. Is it worth it? No. Alright, well there it is. These flats are a bit annoying, but it doesn't affect the function of this at all. I'll probably just blend that with a file, I think, and then powder coat it. So that can go in there, and we can index that wherever you want it to go. And I've ordered one of those little lever handles with an M8 thread on it, so I don't need to use this hex key. And that just locks off wherever you want it to go. And these can just fit in, and you can turn them 90 degrees each time. And although the fit's not brilliant, that's just how they are. That's just a function of the fact that this is forged and they're all a bit imperfect. This one here is called a hatchet stake. This is used for bending 45-degree edges on a piece of sheet metal. And of course, if that's not comfortable for you to work at that position there, you can rotate that wherever you want it to go. Right, I'm going to go ahead and I'm going to get the vise finished. It's going to be powder coated. I've got to make new jaws. We'll get this powder coated. And I'm going to get the little anvil with a spigot mounted on it, and we'll come back and look at all the bits all done. Okay, quick update. I couldn't stand the flats that were on this socket here, so I put weld over all of the flat parts and remachined that, and that's come up pretty good. With the vise mount, I've cut the base now to match the base of the vise, so it's just a neater arrangement, I guess. And I can rotate like that. And here's the anvil, and I know it's not really an anvil, it's just a piece of railway track, but it does the job. And again, I can rotate that wherever I want it to go. So I'm going to go ahead now and get everything cleaned up, and I'm going to do some powder coating. I may zinc plate this part here, because really this section here can't be powder coated, nor can the inside. So, and that's simply because it won't fit in the socket if I put powder coat around that area there. So zinc plating will help protect this from rust and corrosion. It'll look good. This part here, I'm not really bothered. I'll clean up the top, just give that a new surface there. Get the vise powder coated, and then we'll see it all when it's done. And please, no snide remarks about my welding. Cosmetically, it's horrible, but it does the job. All right? But have a good laugh now, and then we'll just forget about it. And we're back. Now, I've done a quick and dirty restoration on this Dawn vise. This is a 100L Dawn vise. I powder coated the body and the moving jaw in a powder coat called Black White Vein. I put one new jaw on the fixed jaw, and this one here is the original jaw, but I've turned it around the other way so it has the serrated face on the inside here. Now this vise is really going to be used for sort of holding parts while I do some grinding and clean up, polishing. I'll use it for positioning parts for welding and, you know, sort of tapping things and bending things, but it's not meant for precision work. Now, when I used to use this vise over on my general metalworking bench, I had smooth jaws on the inside here, but I want this to grip a bit better. Now the end of the screw and the handle here have been zinc plated, and they've been dipped in a blue chromate dip, so that'll just prevent that from corroding. And of course we can rotate the vise wherever we want that to go, and we can lock it off. So that is as solid as I want that to be on this bench. Okay, let's look at the other attachments. Alright, here's the anvil, and all I did here was I sandblasted this and I powder coated that in a colour called Jotun yellow. And when this goes in and we lock it, it's surprisingly solid. All I did here was I belt sanded the top surface there and these two edges. Now this is going to be used mainly for forging or light forging, not blacksmith work. It's just if you want to sort of flatten the end of a piece of steel bar. I've got oxyacetylene. I can heat that up red hot and work on this. It can also be used for just pressing parts together with a hammer and a drift and so on. Yeah, but super handy on the bench here, and I can put it away when I don't need it, so it's not in the way. Let's have a look at the final piece of the puzzle here. Alright, there's the part that I showed you earlier on, the one that I fabricated and turned on the lathe. Now this has been zinc plated and it's been done in a black chromate dip, which gives it this beautiful luster and provides corrosion resistance as well. But unfortunately, when I did this zinc plating, I didn't go to enough trouble to clean the inside of this. I should have actually cleaned it up before I welded it, but it had black scale and corrosion and so on. I tried to remove that by pickling this in hydrochloric acid, and it sort of worked, but obviously it didn't plate all the way to the corner, on the inside corner here, and certainly hasn't plated inside there. Now I may do this in a Parker phosphate coating later on. If I get the gear out, I can do it. But just at the moment you can see that there's actually no zinc on these edges here. But luckily there's a fix. Now it's a bit technical, but I'll show you anyway. You might need to get your notepad and pencil out. Alright, now you can see the corrosion down inside there, so we don't want that to happen around the top. So how do we fix that, make it look uniform? Alright, now here it is. Now like I said, it's a bit technical. Well, there it is, all fixed. Yeah, I know, it's a really bad joke. But next time I got the Parker phosphate kit out, I'll probably do it that way. Okay, let's put this one in the socket and see how it looks. Okay, well there it is. And we can just put that stake in there. We can turn that wherever we want it to go. We can take it out when we don't need it. And this can come out as well. And I can put that away now. The top of the bench is now clear of any obstructions. This just sits near the corner of the bench. It's fairly unobtrusive, so I'm totally happy with leaving that where it is. I don't need to undo these screws and remove that part normally. So that's it, guys. That's just my little trick for mounting stuff quickly. And it may be that I'll find other accessories that can go in here, and I just make up sockets to suit, or spigots to suit, I guess, and mount those in there and quickly, maneuver them where I want them to go. Alright, now that's all for today's video. Thanks for watching. Also like to thank all the people who put in entries for the 15,000 subscriber draw. Now I did say I was going to limit this to subscribers only, but it's very hard for me to tell from the people who put in comments whether they are subscribers or not. Apparently they only show up as public subscribers, so if they haven't made that public, it's hard for me to tell. So stuff it. Like at the end of the day, just if you put a comment in, you're in the draw. I don't want to make this a mission. So in another 2 weeks roughly, I'll be doing the draw, and tune in then. There'll be an announcement, and I'll get those things out to you. Alrighty, it's Prezzo signing out for now. Thanks for watching, and I'll see you on the next video.